Hello, I'm Brock Mason, and I'm the captain of the rocketry team here at SWOSU. I'm a junior majoring in engineering, physics, and mathematics. I work with just about every aspect of the rocketry process. I specialize in logistics and our onboard electronics. Let's start by meeting some of the members of our team.
Hello, my name is Cameron Cinnamon. I'm a senior double majoring in engineering, physics, and math. I work with our recovery systems, specifically using black powder charges for dual deployment.
Hi, my name is Daniel Gassen. I am a senior in engineering, physics, and math. I assist with dual deployment as well as recovery of the payload.
Hello, I'm Tayler Valdez. I'm a sophomore majoring in engineering and physics here at SWOSU, and I mostly handle rocket construction and quality control.
3, 2, 1.
So the first rule of the competition is one team member must be certified level 2 at Tripoli. We have went to Argonia multiple times this season, and we were able to accomplish this. Our team had 3 members successfully certify level 1, and I was able to certify level 2. Since we wanted to be as precise as possible, we chose to build the kit for this competition. We chose the Wildman 3 dual deploy rocket. It is still under construction, but we estimated the weight will be around 12 pounds. Once it is loaded with a motor and electronics. It is 85 inches tall, which helps us a lot with our stability. We went with a fiberglass rocket with an aluminum tip nose cone, since some of the motors we chose make the rocket go as fast as 1100 miles per hour. We have not chosen a specific motor, but have narrowed it down to 3. Our 3 motors are the K1050, the K270, and the K850. We plan to fly all 3 March 8th to see which one we will choose to fly in the contest. We use OpenRocket to design and simulate all of our flights. It is a free software and very accurate. It closely compares to our actual flights in terms of apogee and speeds. Here's the OpenRocket file of our rocket. We are using dual deployment, so there are 2 parachutes on board. As you can see, the rocket will reach apogee at 9,500 feet. At apogee, we will deploy our drogue chute. Our drogue chute is 15 inches in diameter. Our main chute is about 50 to 55 inches in diameter, and it is set to deploy at 600 feet. To make our rocket land as close as possible to the pad, we decided to go with dual deployment. Dual deployment for us is 2 black powder charges set to go off at different altitudes. One will go off at apogee, and it'll release a small drogue chute, and a bigger one will go off at roughly 600 feet. It is standard for most high-power rockets, so we figured we should adopt the practice. We will have 2 Altus Metrum Easy Minis on board. They will be powering our dual deployment. We will also have a Jolly Logic Altimeter 3 on board to give flight statistics. We will have GPS tracking with a MissileWorks T3 or our own in-house GPS tracking. Earlier this season, we were able to create our very own altimeter using an Arduino Mega and a BME 280 pressure sensor. Our dog altimeter was able to give us the same reading as the commercially available one we had on board. We also have had 2 successful GPS attempts, and we tested our very own GPS tracker. All of our electronics will be fastened to the sled in our electronics bay. We are collaborating with our technology department to 3D print an altimeter-based sled.
We had multiple grand ideas for landing the golf ball safely and at the specified location. We narrowed it down to 3 by October to really focus on a few good ideas. The ideas that made the cut were a drone, a glider, or just putting it in eBay and landing our rocket as close to as possible to the pad. We ruled out the glider quickly because of how hard it would be to fit a glider in the rocket. The drone idea flourished, however. We started building one immediately and were able to get a flying drone by January. The problem is the drone is just too big to fit in our rocket at this time. With more time to upgrade and downsize, it could be an option next year. That left us with our last idea of just leaving the golf ball in the rocket and trying to land it as close to the pad as possible. It is simple and most likely the easiest to execute using dual deployment. We hope this video was informative, and we can't wait to compete in the 2020 Argonia Cup.